In this video, we will compute the Laplace transform of the function f of t equals sine of alpha t for some constant alpha. We'll start, as we have before, using the definition of the Laplace transform. We'll write the Laplace transform sine of alpha t as some function f of s, which is defined as the integral from 0 to infinity of e to the negative st times our function sine of alpha t dt. For this integral, we are going to need to integrate by parts, using u equals e to the negative st and dv equals sine of alpha t dt. Using these, we get that du is the derivative of e to the negative st, which is negative s times e to the negative st dt. And v is the integral of sine of alpha t dt, which is negative 1 over alpha cosine of alpha t. Integration by parts tells us that the integral of u dv is u times v minus the integral of v du. So this gives us that our improper integral is the limit as b goes to infinity of negative e to the negative st times cosine alpha t over alpha, evaluated at our bounds from 0 to b, minus s over alpha times the integral from 0 to b of e to the negative st times cosine alpha t dt. Evaluating the first part at 0 and b, we get negative e to the negative sb times cosine alpha b over alpha plus e to the negative s times 0 cosine of alpha times 0 over alpha. But as b goes to infinity, e to the negative sb goes to 0 so long as s is positive, which means that this entire first term goes to 0. Now for the second term, we have e to the negative s times 0, which is just 1, and cosine of alpha 0, which again is just 1. Meaning that this first part simplifies to simply 1 over alpha. And the rest is negative s over alpha times the integral from 0 to infinity of e to the negative st times cosine of alpha t dt. Now again here, we are going to need to use integration by parts, using u equals e to the negative st and dv equals cosine of alpha t dt. Doing this integration by parts, this will simplify as 1 over alpha minus s squared over alpha squared times the integral from 0 to infinity of e to the negative st times sine of alpha t dt. But this integral is f of s. So we get the equation f of s equals 1 over alpha minus s squared over alpha squared times f of s. Solving this algebraic equation for f of s gives us that f of s is alpha over s squared plus alpha squared. So we can conclude that the Laplace transform of sine of alpha t is alpha over s squared plus alpha squared for values of s bigger than 0.